Hello! In this video I will explain you the use and functionality of CPU markers and jump addresses. Jump addresses are used to structure your logic. To put it simple, you could also see a jump address as a wire with a name. Wherever you have long wires or want to jump to another page, just use jump addresses to give your logic a better structure. We now want to restructure our logic to 3 different pages: the inputs, the reset and the restart. Therefore we add 2 new pages by clicking the Add New Page button. Now we are going to rename them by clicking the Rename Current Page button. In this example I will rename the first page to Inputs, the second one to Reset, and the third one to Restart. On the first page I only want to keep the E-stop and the light curtains, as well as the end block. So we cut out the reset block and its attached elements. They will be added automatically to the clipboard here. On the reset page we can drag them in the main window again. The same we will do with the restart block and its attached elements, and place them on the restart page. Okay, back to the input page. Now the output node of the end block is not connected. That is where we will use the first jump address. A jump address consists of a source jump address and a destination jump address. The destination jump address takes the value of the source jump address without any delay. To add a source jump address, we click on Add Source Jump Address and drag it into our main window. A new window pops up telling us to create a name for our new jump address. We call this one Save Shutoff and hit OK. After that we can wire it to the function block like every other output via simple drag and drop. On the second page, the reset page, we now need to connect the input of the reset block with our jump address we just created. To do this, we drag the Add Destination jump address to our logic. Again, a window shows up and asks us to select the source address. In this drop-down menu, we will find all available addresses. Choose the Save Shutoff and click OK. If we now connect it to the release input of the reset block, it will be the same as if we had connected our end function block from the other page directly to it. With the same technique I finished the second and the third page and added a node to every page. Now we have our logic arranged on 3 different pages. The use of CPU markers works basically in the same way as the jump addresses. CPU markers are available as in and outputs here. And contrary to the jump addresses, there is always a delay of 1 logic execution time between the output marker and the input marker. The CPU markers can be considered as variables, which are readable and writable. Therefore, they are available for gateway routing and other diagnostic purposes. In our example application, we want another lamp to show us if a reset is required, but contrary to the lamp we already have, we want this one to be switched on permanently as soon as the conditions for reset are fulfilled, but the machine hasn't been restarted yet. Therefore, we need another end function block. Now we connect this block with the release condition fulfilled output of the reset block and with the enable output. However, we need to invert this input, because we don't want the lamp to be on if the machine has been reset already. Therefore, we right-click the block and choose Edit. Here we can check the corresponding box to invert input 1. Now we can add our marker to the output of our end block. We also need the input counterpart of our marker, which we find under Inputs. Now it's important to use the marker with the same name as our output marker. To add a lamp to the output of the marker, we need a routing block. With the known technique, we change the amount of in and outputs by opening the context menu of the function block. All that is left to do is to add the lamp. That's it so far for this tutorial. We now have a structured logic and a constant reset required signal instead of a signal that is pulsing at 1 Hz.